Yeah, hello. We're really sorry that this break is rather short, right? And there's maybe not enough time to get coffee, but there should be more time to get coffee after this. As you can see, we are still preparing, right, and then setting up. So in the meantime, I mean, we'd like to know you, right? Who you are. So let me ask you this question: Who's a developer? Nice. Who's a Java developer? Okay. Who's a developer but not Java? Okay, we'll show you how to start learning Java. That's nice. Who's not a developer at all?
Can you have them show our screen, please?
Marit, we have managers in the room. Sorry. Yeah. Yes. One more thing, because we'd like to establish what version are you on. Okay. Who's running on Java 26?
Anyone?
You're in a good room then. Very nice. Java 25 in production. Okay.
Good.
Oh, yeah.
We have a few
yeah.
people running Java 25 in production. Nice.
Very nice. Yes. What's then? 21, 17, 11.
A few. Someone in the back.
Maybe 8. I don't steal people on 8. Sorry.
So we're going to show you some of the nice things that you can have that are newer than 8.
Yeah.
And maybe also give you some ammunition to use to convince the people who might be stopping you from updating.
Let's start then. Could you please do the
yes
the thing?
Let me just close this one.
Yeah.
And then here we are.
Here we are. Yes. So welcome to the session, Learning Modern Java the Playful Way. Long title, I know, but it's Java, so it has to be verbose. With
filing paperwork with semicolons, right?
Yeah, with me there's Marit van Dijk. Marit works for JetBrains.
And with me from Poland, Piotr Przybył, who works for Elastic.
Yes.
But more importantly, we are both Java champions. And also...
Spoilers alert.
We are friends. So if we are goofing off together, it's okay. We are very good friends.
Okay. We do, but okay. We covered who you are, lovely people, right? What version you're running and so on. So do you recognize yourself in the picture?
Especially the gentleman on Java 8. I'm so sorry. So we understand that, upgrading sometimes can be hard. You might need to convince people to let you upgrade. But also you might have the opportunity to wait with upgrades. And unfortunately, some of us do not. As mentioned, I work for JetBrains. We make IntelliJ IDEA. And we support new Java versions from day one. And we also try to support preview features and incubator features so that you can already play around with them in your IDE and support early access versions, etc. So we don't actually have the option to wait to upgrade to newer Java versions. As for Elastic...
Yeah, the same goes for Elastic. Elasticsearch, kind of like data store written in Java. So naturally, you want it to run on the latest version because the latest version is the greatest, the fastest, and so on, right? So like 2 versions ago, there was this thing with security manager being removed. So, engineers had to work around it and so on. Not easy. We know it. How painful can it be? So that's why we decided to help you maybe a little bit with this migration. Okay, so the agenda for today, we'll be playing, of course, goofing around, but we'll be showing you various features from recent Java versions. Not all of them, unfortunately. We don't have a deep dive. We don't have a whole day workshop, right?
We have only 40 minutes.
Yes.
But obviously, we're going to use demos. If you know either of us, we like to do demos, obviously.
Yes.
And like we said, we like to play around with the new Java versions, basically learning by playing the way that children do.
Yeah. If it breaks, it breaks. Yes.
Hopefully it won't.
What do you see here? What do you see here? The wall of text, right? So of course, I suggest you go through this list of the JEPs, at least for every major JDK release, right? So in this 26, we had more Amber. The Loom is maturing. There's Panama and Vector API progress. There's groundwork for Project Leiden, so faster startup and so on, and more security and so on and so on. But then Java 25, only 6 months before, okay, there were changes to performance, better garbage collectors, compact object headers, right? That's also a very nice thing. More concurrency goodies, we'll be showing them. Better observability and profiling, thanks to extensions to JFR. There was great stuff for newbies and prototyping, so if you don't habla Java, you're in a good room, okay? And there's
It's
more.
never been easier to get started with Java.
Exactly,
really.
it's never been easier, and we really would like to show you that. And about that, yes. There's this thing, like people say that Java is not good language to start with. You can't simply put someone in a chair and start teaching them programming and use Java. You cannot do it simply. Question.
What language is this? Don't be shy.
Look, I have stickers for everyone. Come and grab them. And I have extra swag for people who'd like to play with us. So what language this is? Who said Java? Come later for extra swag. Okay, yeah, this is Java. This is Java 26, exactly, right? And there is some other language. People say this other language is maybe better to start teaching people programming. Well, is it really? Because to make it run like properly as entry point, you actually need to add these 2 lines. Okay, so as you can see, these days Java is more concise.
Are you saying it's less verbose than the other language that is supposedly the best language to learn programming?
Even with semicolons, yes, exactly.
Cool.
That's the point. So this takes us to the first feature.
Yes, so what we just showed you is part of compact source files and instance main methods, which is a standard feature as of Java 25. And as you can see, instead of having to declare a class and public static void main, we only need void main, and we can also use the new convenience method IO println. We can use an import for IO, but we don't have to, and actually having it right there makes it clear that it is an IO method.
Yeah, so as you can see, when we don't have a class, we are down one problem, right? We don't have to name it. As you know, there are 2 big problems in IT, okay? Naming things,
cache invalidation,
and
off by one errors.
Yeah, off by one errors, exactly. And there's the other thing. I know some people maybe are not that happy that public static is gone from main.
I'm a little sad.
Yes.
Because I read a tweet once that said you can sing public static void main to Everybody Dance Now. Public static void main. And I can't stop doing it. And you're going to hear this in your head now too. I'm sorry. Or you're welcome. Pick one. So anyway, but it is easier to get started with.
Yeah, that's just it.
And then on to demo time.
Yes, demo time. Folks, I don't know if you know, but there's a nasty property of demos. Sometimes they just go kaboom, right? So we like to play with demos. So that's why we brought this little lab codes, because, experimenting time, things may go off. Sadly, we don't have the lab codes for all of us, right? So pretend you're also wearing a lab coat, maybe some safety glasses, right? Fingers crossed it works, because it was like, what, 2 or 3 times it didn't work on stage.
Yes, please pray to the demo gods for us. Thank you.
Yes, so let's see how it goes. Yes,
let me explain the demo so you know what you're looking at.
Sorry,
and
the pen.
Smile at my friend here.
Yeah.
Thank you for the pen.
Sorry, I forgot we're taking pictures.
We have pictures of us synchronously putting on lab coats and pens. Thank you, Dimitris.
Yeah, by
you
the way,
know Dimitris, right? Evcharisto. So let me explain the demo. Let's pretend that we are a shop and we sell images that you can use for your presentations or your web shop for your products or whatever. And we're using royalty-free images. Of course, our customers will have to search for those images. So we will use a multi-model encoder, which is a thing that can process different input types, in our example, images and text, and generate vector embeddings for those. The idea being that the text that describes an image, those vector embeddings would be close together. So you can use the description to find the image. To prepare for our demo, we already indexed our 12 images with our multi-model encoder to generate the vector embeddings for them. And we stored them with their file names in Elasticsearch, you know, for search.
Yep.
Gerne. And then when we search for images, we will use that same multi-model encoder to generate the vector embedding and find related images. And we will use hybrid search, meaning we use two different search mechanisms, classic search by text and vector search using the vector embeddings. And then RRF, which stands for
Reciprocal rank fusion.
And we use that to combine the results from those two searches into one ranked list, kind of like Formula One, where you do multiple races and you combine those results for the final list.
Trophy, yeah.
Yeah. So let's have a look at how that looks in the code.
Because in code we trust, right?
Yes, so let's...
Slides can lie. Let's run it maybe, yeah.
Let's run it. What should we look for?
Fruit.
Fruit. So now we see that we find the image named fruit, obviously by the name, but also we find other images, apples and plums, that also contain fruit, because their vector embeddings would be close to apple.
Yeah, let me maybe show that how it works in the sorry,
yes.
which is it? Yeah. So what you see here is the web UI for Elasticsearch. It's called Kibana, right? If you want to run it on your local host, you Google Elastic start local. That will run on Docker, right? And now let me just show you this. We have this index. After this indexing, there's this catalog. We have only 12 documents to keep it simple. And each document, basically, what matters here, has this vector embedding, which is roughly speaking, nothing else by a list of 1,000 floating point numbers. That's called vector embedding, and also the file name, right?
Yep.
And we use one mechanism uses the one search, the other uses the other one. So then, as you can see, this was hit by the classic search, text search. The other one was like the vector search. So the application works. Nice. And it's written in kind of like Java 8, 11-ish mindset. And the whole idea for this talk is we'll keep upgrading it, you know, with the modern Java features as we go. So hopefully the application will keep working. And we see them features
while we refactor. So the first thing we want to talk to you about is records, which are a standard feature as of Java 16, and they are immutable, transparent data carriers.
Let me ask, who's on Java 16, 17, and onwards? Again.
And who of you is using records?
Or not using records?
Yes. Check question. So for the record, you should be using records. Let us show you how.
Easy.
It's very easy. If you have a query with vector, a class that could be a record, your IDE can do that for you. And just to show you what the difference looks like. So here we have the class, which has the all of the methods, equals, hash code, etc. The record will automatically generate those for you, meaning that you cannot introduce bugs by writing them incorrectly. It will also generate a toString method, but in our example, we want to overwrite that so we don't print all of the 1,000 floating point numbers, but only the first and the last one. So you can overwrite these methods if you want, but you don't have to generate them yourself. So isn't this much nicer and clearer and
shows the intent, right? Immutable piece of data.
Yes. So another feature introduced in Java 25 is module imports. And let me show you that quickly.
But no tariffs, please. Like just
no tariffs on the imports, please.
Thank you.
And we can import module Java base, because as you see, we have a bunch of imports here that are actually all fairly standard. So if we then optimize imports, and I always forget the shortcut, I know I should know all of them, but I'm also human. And now I can use command completion or ... to find...
I feature. I call it the I feature. Sorry. Do you know Morse code? In Morse code, this is I. Sorry.
Yes.
I can't.
Thank you, every time. And so now you can use ... to find the relevant commands, in this case, optimize imports. So we see that we have a shorter list of imports. If we want, we can replace them with single class imports, but we don't have to.
Yeah, and I don't know if you have it in slide. Yeah, it comes with simple I/O, but also what's important, if you have this, compact file, the import module Java base is already there. That's why when you have void main, you don't have to import anything. For example, to call list.off, okay? Because it's
Exactly.
implicitly imported. Yeah, and
Right.
who has suffered in your life when you were learning Java with scanner to read something from keyboard? Yeah, we suffered
Or
too.
worse, input stream.
Input. Yeah. Okay. Yes. Now.
But now we can use, as mentioned, the convenience methods, like not just print line, but also read line, which is actually an overloaded method. So we can pass it a string that will be printed. So we can put this here, and then we no longer need the scanner or to print this to the console. And then if we run it, what should we look for this time?
Orange.
Orange. And here you see that again we have fruit.
And you might be wondering why. Please demonstrate.
So let's have a look. It's an orange. So that is the first result for orange. So also this is, just a little bit nicer and more concise. Next, stream gatherers, which I know you can talk about for at least an hour because he has.
Yes.
So there is a whole talk with Piotr about stream gatherers if you want more information. But please, can you explain it to them briefly and concisely this time?
I will try. So first, let's establish common ground. Do you also work on programs or systems where the sole purpose of the system is basically take a pile of data and shovel it to another pile of data, only transfer it, modify it? Yeah, I see like many people nodding. Exactly.
Yep.
So for such data-driven flows, Java is moving forward, right? You will see pattern matching later, but also, this is nice to process this data in declarative way using streams. The problem is when you need a fancy collector, you can create fancy collector, but we cannot create a fancy map or filter, right? We're bound by the API. So now there's a new method, right, called gather, and using this method, we can replace, in theory, everything like filter, predicate, map, flat map, and so on, because this is entry point for a custom intermediate operation, basically. And there's like more sources if you fancy to watch or read. This is like or watch, I guess. Anyway,
yes.
Yeah, let me show you that in code because I really, really prefer doing things in code. And now let me zoom it my way. I prefer this way of zooming, sorry. Yeah.
We have different ways of zooming. I like to zoom the entire IDE, so everything is bigger, and he likes to zoom just the editor. And we fight about it every time, but it's okay, we're friends.
Yes, both approaches work.
Yes.
So
which is nice.
You see now this method. Now, and who can tell me, looking at this method, what this method is doing in 3, 2, 1? Exactly. Right. So now let me show you how this method used to look like before it was obfuscated, so to say, on purpose. Let me show you Git and show history for selection, and it used to look like this. So it was using parallel streams. Sadly, we cannot use parallel streams in critical paths because they have like issues, they exhaust the underlying thread pool and so on. So because of this, we had to go for completable futures. But now maybe there's a different way to work around this parallel stream or removing it. So instead of going for map, let me go for this gather method, because what I'd like to show you is, in my opinion, like under-promoted feature of Java 24, and this is gatherers map concurrent. So now I can say up to 5 workers. Let's go to the end. Okay, and I will try to run it now and see how it works. Instead of maybe going this, let me search here. Maybe let me add. Sorry, I can't type Greek, so let me go for German. I hope you don't mind. Apfel. Because also I use some German here, right? Because, so it's oops, that I clicked somewhere where I shouldn't. Where did I click? Yeah, let me go back. I'm so clumsy. It's not exactly my computer. Right, so we'll be looking now, searching for orange, apple, Apfel, Heckscheibenwaschanlage.
Bless you.
Thank you. And computer.
Does anyone speak German?
Spricht ihr Deutsch?
Wer spricht kein Deutsch?
Yes!
Ah!
Ah, come for the swag. It's the first person outside Germany who knows. Yeah, round of applause. Exactly. So you have this lever by your steering wheel, right? When you want the sprinkler device to work and sprinkle some fluid on your rear window, right? So Heckscheibenwaschanlage. Exactly.
Bless you.
Yeah.
What was it?
Evcharisto.
Yatsis? That's it?
Yes.
Sorry.
Let's run it now and see how it works. Okay, so as you can see, it works. It finds something for Heckscheibenwaschanlage, and this is related to, as we can see, irrigation, water sprinkler. There's a car, but interesting results come when you, for example, toss apple and Apfel. So apparently, this thing, this encoder understands many languages. Yeah, this is an encoder from Gina. Gina is not part of Elastic, and here's the difference. Here it shows apple, and here it shows plum. Why? Because here we look for the search. For the string, and that's still the ridiculously priced Apple computer, okay? And here it just looks for fruit, so it gets the meaning. Now, let's get back to the most important thing. When I go back here to this method, where were I? I just lost, yeah, here, okay. Now, when I ask you what this method is doing in 3, 2, 1, is it more obvious what it's doing?
Yes, no, maybe. I see someone.
Yeah, some people like
I see
hesitant.
people nodding.
Yeah, it's basically you see we have stream, we have two intermediate operations. These are like concurrent mappers. We didn't change this, and we didn't just collect a list, right? So I would say this is easier than what we had before because it keeps the semantics. So we will showing now a few features which are still preview. So to run them, toss this switch to your command line, and one of them is structured concurrency.
I love structured concurrency. So it is still in preview. It's the 6th preview in Java 26, and there's already a new JEP with
Preview as well.
with a new preview, 7th preview, where there are some minor changes, but we can already try it out. It really gives us better idioms for a multi-threaded code. It will that actually express the synchronous way of thinking, and we'll show that with an example. But also it can help eliminate thread leaks and cancellation delays. So good candidates to use structured concurrency are any place where you are firing off multiple tasks and then waiting for the result, like we have with our hybrid search, where we do the classic search and the vector search and then wait for the results to combine them. Because in our case...
Feta.
In our case, we want the results from both searches in order to get our final list. In other cases, you might be okay if you hit one of the caches and the other task can then be cancelled. But in our case, if one of them fails, we want the other one to be cancelled. And now with structured concurrency, it's much easier to actually express that.
Let's show the code first.
Yes. So can you explain to them a little bit what this code is doing?
So now we'll be working on this execute search method. So we want to, because I decided to use a free and open source version of Elasticsearch. So we're handling RRF here, like on the client side, right? So we fire one request, which is, you see this vector search. We fire another request, which is classic search, right? So we have two completable features running. And then at the end, what we have to do when we have the results, we combine the results using RRF. But here's the interesting part, which is often skipped by unexperienced junior people and poor AI agents, which is the cancellation, right? Because let's say we have this requirement that we either need everything or nothing. So when one search mechanism fails, we want the other to stop working because it's just wasting time, CPU, resources, whatever, right? So when we have two search mechanisms, one has to cancel the other and the other has to cancel the first one, right? When we have three, let's say we would have three, then we would have how many cancellation paths? Come on, do the math. It's difficult, but it's 6, right? It's 6 because it's every has to cancel the other 2 and so on. When we have 4 of such mechanisms, best you can do is Macarena, right? Because it's that difficult. Or maybe not difficult, but like boring and so on. So now, please...
I don't really want to write the code to cancel all of the things. And with structured concurrency, you actually don't have to. So let me show you what that looks like. And maybe you want to tell them what I'm doing while
so Marit used inline template, if I'm not mistaken, right?
Live template to...
Yeah. to have
scaffold the structured task scope that we will use.
Yeah, and now we have so we try with resources. We have this structured task scope, right? With the open, we go for the defaults, which is everything or nothing. And now what we have inside in this scope, we have to fork subtasks. As you can see, it's already saying it's going to be a subtask or something. So we'll have two subtasks for vector search and for classic search. And yeah, and then after they both done, we have to sort of park at the join method. So everything has to get to the join. If you forget the join, don't worry. The compiler will tell you. Not yell at you. It will tell you because compiler is your friend. Okay, we always pair programming with compiler, and then yeah, we'll return it.
Please tell me you don't have this in your code to do handle exception.
Do you have in your code this comment in catch close will never happen? On my behalf, you're free to write the system exit 1. It will never happen.
It will never happen. So now that we have this,
the favorite part.
Yes, it's my favorite part. Deleting code. It's the best. All the way down. Oh.
Yeah, keep deleting. Keep deleting.
It's not my mouse. He wants to bring the mouse. So.
Yeah.
Okay. And then, oh, wait, I forgot to do another nice thing.
Yeah, list.
Which is we can use list, list of, and then get the result for KNN search and the result for classic search. And now let's run it again.
Hopefully it works. And
yes,
it does.
It still works.
Yeah.
So now we have this
question.
Isn't this much clearer? It clearly expresses that we have the structured task scope, we fork the tasks, we join the tasks, and also we can configure what we want the tasks to do if one of them should fail.
Yeah, so you see this structured concurrency in code, it's guarded by the compiler, it's no longer a gentleman agreement, right? I cannot leak this scope outside as I could leak, for example, threads or completable futures. Right.
Yeah. And if you run it through the debugger, then the debugger will also show you the task scope with all of the threads that are contained therein.
Yeah, back to the slides, because we can, like if you need to, you can configure it a bit. For example, we can go for custom open. As you can see, we can select a different one, but this is still the default. I can have this nice, like, this pattern doesn't have a name, but it's like a lambda builder configure something, so we can name it to be easily seen in the debugger. We can change the timeout, we can change the thread factory. By default, these are virtual threads. Maybe you want to have a good old-fashioned threads. I don't know. So as you can see, this is tunable as well. Yeah.
So like our good friend Dr. Venkat says, completable future has no future. We agree.
Yes.
Custom memes for the win. And then finally, we want to show you lazy constants, which were stable values in the previous Java version, but they're immutable thread safe and most importantly, lazily evaluated. So these are a preview feature in Java 26. And also to show you what that looks like. Here we have an object mapper and an HTTP client, which would be instantiated every time this class is instantiated. Right now, as a final variable is eagerly evaluated. But if we make it a lazy constant, it will be lazily evaluated. So let me make a lazy constant of HTTP client. And then here also a lazy constant of, which takes a supplier, as you can see. So let's make this a lambda, and then we can actually use a method reference here. Now we see that our code doesn't compile. So when we go to the error, that's because here we have to first get the HTTP client, and that's where it will actually be evaluated. So only when we need it on demand.
Yes, and you can do that with other stuff, right? For example, with object mapper, which means this object mapper won't be instantiated by the class loader when we, bring everything up, but only, for example, when the first request hits our microservice, right? So
So that will improve the startup time because it's not instantiating everything all at once, but only as you need it on demand.
exactly.
What does this slide mean again?
Have you ever been again in a situation when someone decided to save some time, let's say 2 hours, on reading documentation and instead spend a whole week implementing something?
Yes,
Exactly.
days of coding can save hours of reading documentation.
Yeah,
Yes.
so read the freaking manual, folks. But in order to read the manual, you have to write the manual, okay? And we know that, Java doc is like so much 1990s, right? The HTML, it might be difficult. So now there's Markdown documentation comments in Java, and you can, who knows Markdown? Exactly. Right. So now it's easy to read and write. There's a lovely post by Mala, if I remember,
Yes.
about this. And so how it works, you see now what you can do is basically toss these 3 slashes, and then it's Markdown, right? So you go with the comment. You can go with the backticks for like inline code. You can go for links like this. See, and it's properly rendered in IDE. It's also properly rendered in the Java doc. The Java doc tools also know it. Knows it, so it just works. So now there's one less excuse to write it, and if you're still bored, there's something you can use for this.
You can use AI, because who likes to write documentation? A few of you. Thank you, my fellow documentarians. But for the rest of you, you can have AI do it. No excuses. And if it generates Java doc in HTML, your IDE can transform that to Markdown.
But there's more. Staying up to date means more than just bumping dependencies in POM or like installing new Java version. It also means that we have to change something in our minds. And let me show you quickly what I mean by this. So let me bump to it's not the latest, but let's say moderately fresh version of Elasticsearch client. And now hopefully it doesn't work. Yes, it does not. So as you can see here, creating Java client for Elasticsearch takes some effort, right? Or used to take some effort, shall I say? Because now what you can do is Elasticsearch client dot off. Okay, I shall close this and we'll open this scope. And now it's again this sort of like Lambda configurer. So the config should take like what? Host and API key. And now I will do what you're good at deleting code. I'm good at copy pasting code. Let's see about this. Let's not brag before it's actually done. So this should be the API key. And for the love of Pete, folks, never ever hard code secrets in your code, right? Don't commit .env files and so on. Okay, and I didn't name it, so I also have to go. Maybe let me go with enter here and enter here, and somewhere here I should go like var. Yep, and let's call it ES client. That was the name. Thank you again. Naming is difficult. I did something incorrectly. What was it? It was expected. I did see. I made somewhere. I made a typo. Where is is this one too many or what? Or one in. Oh, what?
Or do you want to go to the other branch?
Let me go to the other branch. Sorry. See, when stressed again, it's. Oh, maybe let me check if this Command Shift Enter works. No, it doesn't here. It won't help me. Let me go then to first. Let's roll back everything. That's the way I do it. Here, and let's check out the branch. This, by the way, also shows you. Oh, thank you for bookmarking this for me.
You're welcome.
This shows you that you can also fetch this code from like online, right? Because it's there. And now, as you can also see in the enterprise search integration test, it's also easy now to create the client, right? So instead of many lines, I can just have this host as the client and username and password, and that's it. So this is, now the message to signal is ratio is very good, and that makes our life easier. So see, this what I want to tell you is it's not just about bumping numbers and refreshing dependencies. It's also if not predominantly, about changing how we think about stuff. See, so it wasn't agreed, of course, between Elastic and Oracle, but suddenly both companies went the same way and used the same new idioms. So as you can see, Java is more and more concise, shorter, and easier to use, I hope.
Yeah, and that's one of the things that I like, is that the language evolves, but also all of the frameworks and libraries evolve with it.
The whole ecosystem,
so, you
and
know,
the tooling and everything. And
that's a good reason to also stay up to date, so that you can move with the ecosystem. Because we're running out of time a little bit,
let's show it quickly.
Show quickly pattern matching with primitive types. So you can now use all primitive types in switch and instance of. So if previously you had these long if else, where you couldn't use a switch statement, now you can. So you can actually use a switch statement, and you can have multiple cases if they lead to the same result. You can have a guard clause, and the compiler will also check whether it's exhaustive. So if your default branch is missing, it will actually yell at you. Of course, your IDE can convert one into the other. So
yeah, maybe not use it with Boolean, as you can see.
You can use it with Boolean, but maybe you don't want to. I don't know if that's necessarily easier to read. It's definitely longer. So, know the difference between if statements and switch cases. And then finally, what does this slide mean? Why is there a dragon?
This is the demo that Marit promised you before we really started, right? What we're showing you is nice. I hope you like it, and when you go back to work on Monday, you just, I want to use it, right? But we love it as engineers. But how to convince the so-called gold dragons so they can toss some coins, some gold, so we can actually offer them new shining machinery, right? After they give budget, for example, a sprint or half a sprint to modernize stuff. I'm not telling you we should modernize everything, but at least let's say the key parts, maybe they would use some love, right? Or the new stuff, something like this. So this is this demo. We'll be using here Vector API from Project Panama, which is still incubating for very good reasons. And this will be what we'll be doing, but maybe let's start some code now.
Yes.
The question is, maybe I'll ask the question after we start.
Yes, let's run it first.
Let's run it first. If it runs, let's see if it runs.
Don't jinx it. So it runs, and we're looking at the comparison of scalar and vector. And why is it so fast?
Yeah, we have two implementations of the same algorithm, and one is Scala and one is vector. And as you can see, the vector one is blazingly fast, and it's because it's doing nothing. I mean, you can do nothing really, really fast and efficiently, right?
Exactly.
So now the point is, let's use Java Vector API from new Java to have this implementation.
Yes.
Who in this room can do that? Who can help us?
Okay.
Exactly. So now maybe let's try, play a little bit with these AI agents.
Yes. So you know why AI is faster at writing code? Because it uses all 12 fingers. Anyway, so let me...
We are dad joke aficionados.
Yeah. We'll put a form up at the end. You can send us your best dad jokes. Come on. This is gonna... Maybe in the meantime, okay, well...
Yeah, how about...
Okay, we did say demos would blow.
Yeah, let's check this out then.
Yes, so I did a dry run just this morning with Codex, which gave us this implementation.
Let's run it then.
Let's run that. So if we run this, we see that the vector is sometimes almost 2 times faster, but not everywhere.
Yeah, so as you can see, it's sometimes it's faster, sometimes a bit slower. It depends on the algorithm. Maybe we could rerun it and see the
if it's still the same every time.
It's still the same, because it's
yep.
see now the results are different because maybe we have different RAM allocation and so on. Let me maybe quickly explain how it works. Okay, so let's say we have this task. We have 2 arrays, array A and array B, and the task is the following. Let's take the first 2 elements from each array, sum them up, and store in array C, right? This third array. And how we think about this task, intuitively or naively, maybe I would say, is just do something like a for each loop. For I equals 0 and so on and so on. But maybe there's a more efficient way. And why? Because what's the size of integer in Java? yeah, people are say 32 bits exactly. And let's say you have like a moderately modern CPU and it has a register of size 128 bits, which means if we put one integer, 3/4 of this register is wasted. So instead of wasting it, what we can do, we can store 4 integers, right, in one register, 4 integers in another register, run a single instruction. That's why it's called single instruction multiple data, SIMD, and then we have the 4 results immediately. It won't be 4 times as fast because we need to fetch more data, you know, cache misses, memory collocation, and so on. But as you can see, in many cases, it is indeed faster. And now it depends on your algorithm. And you may say, oh, this is fancy stuff. Nobody is using this. I hope to prove it false to you because, different performance characteristics.
Also, please note that this is not an official benchmark. You can't do badly at a benchmark if you create your own. This is just us playing around and just having a feel for whether it's faster and what is faster.
Yes, and see, this is like when you run, as I told you, this elastic start local, and when you run this command, this is what you see. And as you can see, it is using Java 25. And you may ask, why not Java 26? Well, because this version I'm running here was released still when Java 25 was the latest, right? Yeah. And as you can see, this vector module is enabled by default because that means that the vector search will work faster. That means that the new language, ESQL, PipeQL, will work faster, right? Because it's using this extra CPU power you have. So as you were able to see, sorry, let me go back here. We didn't change, the results, as you can see, are still the same, right? We still get the same numbers. We didn't change the computer, but somehow, for many cases, we have better results. Which means we spend less time, which means we spend less money and generate less CO2. Okay,
so that's an argument that you can use to maybe explain the people holding your budget why you should be updating your JDKs and also some of your code.
The critical parts.
Exactly. So we played with a bunch of things. We won't read the list. You can read yourself. Each Java version is easier, faster, better.
Scooter.
Every time. And still free. So, you know, why not use it?
Yeah. Question has to be asked. Who is on LTS version only? Okay. Who knows what S in LTS stands for? Support. Okay. Do you pay for support in this LTS version? So you don't have the support you're sticking to anyway. So why do you stick people to LTS version? You have to upgrade Java version every 6 months because of security updates anyway. So why stick to 25 or 21 or 17 instead of going to the next one to get like a better performance, better garbage collectors and stuff, right?
Okay, so, you know, all in all, pretty good for a dead language. Let's quickly skip this slide before Piotr starts ranting. As always, please provide us and all of the other speakers with feedback. There should be a QR code on your badge to go to the mobile app where you can rate the talks. Please do so for the speaker's sake, but also for the conference sake.
Yeah.
So if you like this talk, please give us 5 stars.
Yeah, how Pat and other
app.
Folks should know if you like the talk or not, or like
Exactly.
if there's something about the room or not, if you don't speak. I mean, this is the way for you to speak, right? To provide you, like, you know.
Yep, and it helps out the conference organizers.
Yes.
So if you want to talk to us directly and provide us with your feedback.
For example, because you're watching this on YouTube, right? So then you can do this first QR code and let us know what you think directly because you're not attending this conference.
Or send us your best dad jokes.
Yeah, please make sure you hit like and subscribe.
And don't forget to click the bell button. And if you want the code for our presentation or links to the slides or any other links that we had in the presentation, you can go to the second QR code, which will take you to my website where all of the links are, as well as all of my socials. His socials are also on the slides if you want to connect with us afterwards.
If you want to take a single picture from this presentation, it's the QR code on the on the right, sorry. And what, like, we'll be hanging around a little bit because we'd like to get home. It's been a tough week.
It's been a long week. This is our third talk this week in 3 different countries. Thanks for having us.
Please help yourself with the stickers. Grab some for you, for your friends. Yeah, we hope it wasn't too painful, folks.
We hope you were entertained maybe and or learned something. And with that, Evgaristo.
Thank you.
Thank you.